Hi, this instructional video is about scatter plots. Scatter plots. What are scatter plots? It's a bunch of plots that are scattered. It's a bunch of plots that are scattered. It is, really. For example, here's what I explain to my students. Hey, some people, when they get married, as they walk out from a chapel, there is a custom where a bunch of rice is thrown at the new bride and groom. And if we were to throw our rice in a certain direction, let's say, but check this out. So here, it looks like our rice was thrown somewhere from here towards that direction. Doesn't it look like it? And so, what we do sometimes is we try to draw a line that kind of fits through the entire, somewhat of a direction. We're trying to make a guess what it looks like. So we draw a thing called a best fit line. A best fit line. And my estimate of a best fit line goes up from left to right. As I go across from x-axis, it's going to go up as I go along on the x-axis. And this is called the positive correlation. This is known to have a positive correlation. What are some examples of two quantities that may have positive correlation? How about the hours a student studies? If you spend more hours, what do you think will happen to the overall grade of that student? Yeah, as you spend more time studying, your grades will probably go up. That is known as positive correlation. The hours you work out lifting weights will allow you to lift more and more weights as you get stronger and stronger. More cookies you eat. More cookies you eat, you may gain some more weight. Those are called positive correlation. Here's another situation. Okay, so if you take a good look at it, it looks like if you were to draw an estimate of a best fit line, it looks like it's going to go down from left to right. It looks like it's going to go down from left to right. So what are the two quantities that may give this kind of situation? Over here, as time goes by, something gets bigger and bigger. That's called a positive correlation. This one, as time goes by, something gets smaller and smaller. This is called a negative correlation. For example, hours you exercise. If you spend more hours exercising, won't your weight become smaller and smaller? Of course, you'll get more muscles along the way, but overall, your weight will be smaller and smaller as you exercise more and more. How about more hours you study? Maybe less complaints from the parents? Yeah, so as time goes by, when something gets less or smaller, that is called a negative correlation. And how about this one? Alright, are you able to determine any kind of correlation here? Is it going up? Is it going down? Is it going side? What? If you said, I can't tell, it looks like there's no correlation. Exactly. This is called no correlation. When one set of data doesn't seem to relate to any of the other data that you might collect. For example, this may be the shoe size. The bigger the shoe size, maybe this could be your IQ test results. If your shoes are bigger, does your IQ get bigger? No, not necessarily. No. If you keep on practicing that perfect move on the skateboard, will that make your grades go up higher? No. Well, in fact, it might go down more lower because you're not studying enough, but there's no correlation at all. So there you have it. When you take a test about scatter plots, they'll probably ask you, what kind of correlation is this? What kind of correlation is that? And what kind of correlation does this represent? No correlation. That's it. That's all there is to know about scatter plots. So maybe I should give one example. So, there's this man in Phoenix, Arizona, who sells snow cones. They do sell snow cones out there, don't they? So this man's selling snow cones, and just for the heck of it, he started to collect some data. He recorded on certain days the temperature of the day and the number of cones he sold. And provided to us is this data. So here's what we got. Let's say on the y-axis, the vertical axis, let's call this the number of cones. Okay, that's the number of cones sold. And over here, the horizontal axis, let's call this the temperature in Fahrenheit. I don't know how to spell Fahrenheit, so I'll just call it F. Okay? and since, let's see, the lowest temperature given to us is 55. So let's make this 40, 50, 60, 70, 80, 90, 100, 110. I don't think we need anything more than that. Just put it here. Just fill the space. So here's what we got. At 60 degrees, this man recorded, he sold 56 snow cones. So around here, 56. Well, let's see. And the total number of, the biggest is 520. So let's call this 600 cones. So this is 500, 400, 300, 200, and 100. Okay? So here we go. 60 degrees, he sold 56. So we're going to estimate like over here. Here, let's use this pen. At 60 degrees, 56, something like that. There it is. At 90 degrees, he sold 400. Oh, yeah. At 90 degrees, 98 degrees, he sold 400. Way up here somewhere. Okay? At 75 degrees, he sold around 108. There you go, 75, around 108. At 102 degrees, it does get hot out there, I'm sure. He sold 520 snow cones. That's a lot of snow cones. Okay? So 500 around here somewhere. And at 55 degrees, cold. 42, somebody's still buying it. Yeah. They love that snow cone. Okay? And 80 degrees, at 90 snow cones were sold. Okay, so, so, that's good. All right, still, you gotta eat. And at 9 degrees, nice and warm day, 300. Yeah, now that's a good temperature to be buying snow cones. At 70 degrees, 86. Yeah, very nice, 86, around here. And at 68 degrees, it's a little cold, but 70. Okay? It's not perfect, but here we go. And finally at 82 degrees, this man's pushing the snow cones at 200 of them. Alright, so this data, the plots are not very accurate, but we here have scatter plots. A bunch of plots that are scattered. Okay? And so what we do now is, since we made a scatter plot, we describe the correlation. And to do that, let's go ahead and draw a line that shows the trend. What is the trend? As temperature goes up, what's happening? As the temperature goes up, what's happening to the sales of snow cones? So we're going to draw the best fit line. And to do that, we're going to try to draw a line that goes somewhat through where most of the plots are plotted. So let's say here, There's no real wrong or right way of doing it, as long as you show that in this case, this line that shows the trend is going up from left to right. So now we could answer this question, describe the correlation. This has a positive correlation, meaning as temperature goes up, the number of snow cones sold increases. And so now it says estimate how many snow cones will be sold when the temperature is 80. So based on these, it fell somewhat below the trend, but I'm going to anticipate if it's 80 degrees outside, we'll probably sell anywhere from 100 to 200. At 80 degrees temperature outside, we could estimate the estimate of the number sold is around 100 to 200 snow cones. If you want to make it average and say 150, hey, it's totally up to you. It depends on who's requesting for the information. Hey Johnny, it's 80 degrees outside. About how many snow cones do you think we'll sell today? Probably around 100 or 200 maybe. Yeah, that's how you answer it. And then it says, estimate the temperature when 100 snow cones are sold. So if we sell, or if we are expected to sell about 100 snow cones, we could say the temperature might be around, well, let's see. It could be anywhere from 65, okay, to about 80 degrees. So the estimate of the temperature could be anywhere from 65 to 80 degrees Fahrenheit. Okay? To sell about 100 snow cones, we're hoping the temperature will be somewhere between 65 and 80 degrees Fahrenheit. If you want to sell more, then you better wait until it gets hotter outside, huh? There it is.